This is AS3 2004, question 4. Figure 4.1 is a graph of intensity level response with frequency of the average ear. Note the frequency scale is logarithmic. So you can see there this intensity level scale is opposed to an intensity scale which is in watts per metre squared. And you can see the frequency scale then is a log scale. And this is the area that you can actually hear in here. The graph shows a minimum, which is there. What is the physical meaning of the fact that the graph shows a minimum? So this is the quietest sound that you can hear, and it's called the threshold level of hearing. And your ear is most sensitive at this frequency. So this is the threshold level of hearing, or the quietest sound we can hear. And it also corresponds to the place where your ear is most sensitive. At this frequency. Use figure 4.1 to obtain approximate values for the intensity level of the threshold of hearing and the frequency at this minimum. So if you have a wee look there, you can see the frequency is minimum there, somewhere between 1,000 and 2,000. We'll say, sorry, 1,000 and 3,000, which is probably about 2,000 there. And also then this corresponds to, if you look right across here, in fact if I set my pen down just to see, it corresponds to 0 decibels, or just above it. And so those are the two values that we're going to write down here. The intensity level is 0 decibels, and the frequency is approximately 1,500 to 2,000 hertz, somewhere in around there. I put 2,000 in there, I think. 2,000 hertz. Next part of the question, part B. Music is being played on a CD player, producing sounds at an intensity level of 20 decibels. Use figure 4.1 to deduce the approximate levels of the frequency range of the music that is heard. So if we go back to the graph, 20 decibels there. If we put that down, I'm just going to set it over the top. There's 20 decibels there, roughly. That line is across from 20 decibels. And if you go down to the two edges of your curve, you can see that you're reading there at about 300, and over at the other end is about 10,000 hertz there. And so those are the two ranges. Now if you drew that with a ruler and a sharp pencil, you probably get that much more accurate. But 300 it was, to roughly about 10,000. And there's always a plus or minus in here that you could read that off. An electronic circuit in the CD player switched on, boosting the intensity level by 20 decibels. State the difference this makes to the music that is heard. So that means that your intensity level now goes up to 40 decibels. So if you have a wee look at your 40 decibels, you can see that you're actually hearing a much lower frequency, maybe down to about 100 hertz, but not much more frequency in the higher end of the scale. So the lower end is much more marked. And so to get 2 marks or 3 marks there, you now suggest a range, and the new range from that graph is at about 100 up to about 15,000 hertz. It's a louder sound because the intensity level has obviously increased, but it's more marked at the lower frequencies. So you can hear right down to 100 hertz. And then there's a wider range of frequencies would be another acceptable answer. So there's 4 different answers there that you could get 3 marks out of, any 3 out of those 4.